While everyone was debating ChatGPT versus Claude, Anthropic quietly released something in November 2024 that could be far more important than any single AI model. A protocol that's being called the HTTP for AI agents. MongoDB, PayPal, AWS, and even Google and Microsoft are racing to integrate it, despite being fierce competitors. The Model Context Protocol isn't flashy. It's not a chatbot you can talk to, but it's solving a problem that's been silently crippling the AI revolution. AI agents can't properly talk to each other or share information securely across different platforms. MCP is changing that, and it's happening so fast that most people don't even realize we're witnessing the birth of the infrastructure that will power the next era of artificial intelligence. Here's a problem that's been hiding in plain sight. Despite all the hype about AI agents, they're actually operating in isolated silos. Think about it, you might use ChatGPT for writing, Claude for analysis, and different AI tools for coding, design, or research. But these agents can't collaborate, share context, or work together on complex tasks that span multiple platforms. The issue runs deeper than just convenience. Traditional APIs, the way software systems communicate, were built for predictable, static interactions. You send a request, you get a response. End of story. But AI agents are dynamic, context-aware, and need to adapt on the fly. They operate with changing goals and evolving conditions, which creates massive friction when trying to integrate with traditional systems. Imagine trying to have a conversation through a series of telegrams where each message has to be perfectly formatted and you can't reference previous messages. That's essentially what AI agents have been dealing with when trying to interact with existing software infrastructure. Companies have been solving this with custom code, building one-off integrations for every single use case. It's expensive, time-consuming, and creates a tangled web of incompatible systems. We've been building the AI equivalent of the early internet, where every website required special software to access it. But here's what's fascinating. The AI world evolved faster than the infrastructure supporting it. We have agents that can reason, plan, and execute complex tasks, but they're trapped in isolated ecosystems with no native way to cooperate securely. Enter the Model Context Protocol, and here's what makes it revolutionary. MCP isn't trying to replace APIs, it's augmenting them with something they were never designed to handle: identity, context, and dynamic access control. Think of MCP as a smart security guard for AI interactions. When an AI agent wants to access a system, instead of just getting raw data dumps, MCP asks, "Who are you? What are you trying to do? Do you have permission to do that?" Then it responds accordingly, granting access, rejecting it, or offering limited functionality based on those contextual rules. But here's the genius part. MCP functions like a smart context-aware gateway that wraps around existing APIs and data sources. It doesn't require rebuilding your entire infrastructure. Instead, it adds a layer of intelligence that makes your existing systems AI agent-friendly. Let me give you a concrete example. MongoDB is using MCP to let AI agents access structured data with precise, rule-based control. Instead of giving an AI agent access to your entire database or nothing at all, you can define granular permissions based on the agent's identity, the specific task it's trying to accomplish, and the current context. Wix has integrated MCP so developers can interact with AI tools like Claude directly within their development environments. The AI agents can access project files, understand the development context, and provide assistance that is actually relevant to what you're working on. The key insight here is that MCP is vendor-neutral and protocol-based, which means it works across different AI models, frameworks, and architectures. It's like creating a universal translator for AI systems. Now here's where the story gets really interesting. The speed of adoption is absolutely unprecedented for infrastructure technology. We're talking about companies like AWS, PayPal, Cloudflare, and even Google and Microsoft integrating MCP within months of its release. Think about how significant this is. These are companies that typically spend years evaluating new protocols, running pilot programs, and slowly rolling out changes. But with MCP, they're moving fast because they recognize this addresses a fundamental bottleneck in AI deployment. Speakeasy CEO Sagorba Chu described MCP as making traditional APIs chat native, giving agents more natural, flexible ways to access services. This isn't just about technical efficiency, it's about reducing the massive engineering overhead that's been slowing down AI adoption in enterprise environments. Here's what's particularly fascinating. Even competing tech giants are supporting MCP alongside their own protocol efforts. Google has agent-to-agent, A2A. Microsoft has their own initiatives, but they're all supporting MCP because they recognize that interoperability benefits everyone in the ecosystem. If you like the video, don't forget to hit the like button, comment below with your thoughts on AI agent protocols, and subscribe to the channel for more insights into the infrastructure powering the AI revolution. This rapid cross-industry adoption tells us that MCP isn't just solving a technical problem, it's addressing a fundamental barrier to the next phase of AI evolution. Companies are operationalizing this protocol, not just experimenting with it. The engineering benefits are huge. Developers can configure access rules at the MCP server level, removing the need for constant API updates or deployments. You define logic once, centrally, and update it as needed without touching application code. This dramatically reduces engineering overhead and shortens iteration cycles. But here's where MCP's true importance becomes clear. We're moving toward a world of multi-agent AI systems, and MCP is laying the foundation for that future. Picture this. Instead of using one AI assistant for everything, you'll have specialized AI agents working together on complex tasks. A research agent gathers information, a writing agent creates content, a coding agent implements features, and a quality assurance agent validates everything. These agents need to coordinate, delegate tasks, and share context seamlessly across different platforms and vendors. Without protocols like MCP, this kind of sophisticated automation would remain fragmented or limited to walled gardens. But with MCP, we're looking at the possibility of true end-to-end AI automation across enterprise environments. Imagine an AI system that can draft documents, pull internal data, execute code, validate outcomes, and coordinate with human team members, all while working across tools built by different vendors, following different security protocols, and maintaining proper access controls. This is where the HTTP for AI agents comparison becomes really powerful. Just like HTTP standardized how web browsers communicate with servers, enabling the modern internet, MCP could standardize how AI agents interact with digital systems, enabling a new era of AI-powered automation. The protocol's vendor-agnostic structure also makes it flexible enough to be layered into future AI workflows, whether those are built on open-source models, closed APIs, or custom in-house tools. This modularity is crucial as organizations start composing agent stacks rather than building monolithic AI systems. Here's my take on why MCP represents such a fundamental shift. We're witnessing the birth of AI-native infrastructure. Just like the internet required new protocols, standards, and infrastructure that didn't exist in the telephone era, the AI revolution requires infrastructure designed from the ground up for intelligent, autonomous systems. Traditional software was built for human users clicking buttons and filling out forms, but AI agents operate differently. They need context, they adapt to changing conditions, and they require sophisticated access controls that understand not just what they're trying to access, but why and in what context. MCP addresses this by creating a bridge between the static, predictable world of traditional APIs and the dynamic, context-aware world of AI agents. It's not just about making existing systems work with AI, it's about enabling entirely new categories of applications that weren't possible before. The rapid adoption we're seeing suggests that the industry recognizes MCP as a foundational piece of infrastructure. When MongoDB, PayPal, AWS, and Google all implement the same protocol within months, that's not a trend, that's a tectonic shift. As AI becomes more sophisticated and autonomous, the demand for interoperable, secure, and adaptable infrastructure will only increase. MCP offers one answer to that challenge, and its early success suggests it might become the standard that defines how AI systems interact with the digital world. The Model Context Protocol might not grab headlines like the latest GPT update, but it's quietly building the foundation for the next era of artificial intelligence. While we've been focused on making individual AI models smarter, MCP is solving the equally important problem of making AI systems work together. This isn't just about technical efficiency, it's about unlocking the potential for AI agents to truly cooperate, automate complex workflows, and operate securely across the diverse, fragmented systems that power our digital world. The rapid adoption by major tech companies tells us everything we need to know. MCP isn't just another protocol, it's the infrastructure that will enable the AI-powered future we've been promised. And that future is arriving faster than most people realize.